Hello, Professor J. It's Math with John, and today I have exam two problem. It doesn't have a number, but let's do it. Let's see. So we have. Well, actually, I remember last time you told me try to use it sideways. So let's just do that. Let's try to use it sideways. So it was y equals code, well, inverse code, and then 5 log, and then we have the base 7 and the x, then a plus sign squared, and then we also have the, here we move this recording thing, and then we have also to the power of x, and then we close the parentheses. So when I solve this problem, I kind of look at it like this, that this whole thing inside is just our stay x. But I also want to take note that we do also actually have a plus sign here. So you see that? So let's do it. And we're trying to find actually dy over d of x, the derivative. We're lucky we don't have to do double derivative. That would take forever. So we have to remember this rule. D over d of x, and because we're dealing with logs here, look, note this part. So I'm just doing that. It's the log base of a, well, and then we have the f of x. In our case, it's just the x. And close that bracket with parentheses. F prime of x over natural log a times f of x. And then we're going to get, I don't like how thick this is. Let's make it a little bit thinner. It's going to be f of x equals x, because if we could look at our f of x is just x. And then what do we have? We have a 5. So I could write 5. And then what do we have? We just have 1 natural log. Then we have this for the base, we have 7. And it's going to be times x. But then if we want to simplify it, it's going to be 5 over, and then I want to put the x in the front to make things organized, natural log of 7. Okay. Now, let's find the other part. I want to find this part of the equation. Let's do that. So we found the first part. Let me circle it or box it in. Put that aside. So now if we have sine squared, this is what we had, I believe. And then we had the 3 to the power of x equals, well, we could also look at it as, it's going to turn into, if we take that, think about it like that, we could, since we have the sine squared, right, and the 3x, and then if you take the power rule, you know how you just subtract it by 1, what are we going to be left with? We're going to have just 2 sine, and then 3 to the power of x, because we subtract it, and yeah. But then, what's interesting is that we could also apply this rule, d over d of x, the b x equals b of x, natural log of b. There you go. This rule. this is gonna help us find the cosine. So now cosine, because we take the derivative of sine, so it's gonna be cosine of 3 to the power of x, because the rule says, yeah, but then we still have 3 to the power of x, natural log of 3. Let me see, and then we could combine it together. Here, let's combine it together. 2 sine and 3 to the power of x, cosine 3 to the power of x, and then we have that times 3 to the power of x, natural log of 3. Okay. I don't know if we can simplify that anymore. Actually, I don't know. So like what I did here, I just applied the chain rule on this part. If you look at this part, that's how I got that. And then I just combined it together. You see? Just combine that with this. Okay, and let me see what I can do here. Well, we do have the double angle identity properties. Let's kind of see if I can remember it. I think it's gonna be like 2 sine x and then cosine x. And then if we have that, since we have 2 sine x, but in our case our x is 3 to the power of x, and then we have cosine, and then in this case the x is 3 to the power of x. So what does that mean? That means that now I can rewrite this as sine 2 times, because we had the 2, x times, now I'm just literally plugging it in, 3 to the power of x, natural log of 3. Yeah, that's what we had. Okay, perfect. And then what can we do? Let's see. Now we have to find the cotangent. Let's do that. Let's see. So we have d over d of x. Then it's going to be cotangent negative, or inverse cot of x. And then equals, make it so you can see it better. And what do we have? Is it gonna be negative? Let me see. Well, we did have the, let me see. Yeah, I'm just gonna take what we originally had. So negative 1 over 1 plus x squared. And I'm doing this because the log. Okay. But the thing is, if I plug this in, right, when we take the derivative, we just take the coat. Let's see. If I try to plug it into negative 1, and then we had 5. Yeah, we have the 5 log base 7, I think. That's what it was, right? And x plus sine. And I think it was sine squared, right? Yeah, it was. Squared. And then it was 3x. And make sure you can see it, my parentheses. Good. This is squared. And then plus 1. It doesn't matter, we could put the plus 1 anywhere. But in this case, I put it over there. Let me see. And then let me move it a little bit, like over there. Okay. But then we had the, remember that thing I said save it for later? So let's multiply that times 5 over x natural log of 7. Okay. Now, what we could do is simplify that. And by multiplying it, we get, what do we get? We're still gonna have the 5 on top. So it's gonna be still negative. And then you see if I make, we're still gonna have that 5 on top. And then plus, and then what happens is sine, yep, the sine. Remember this right here? That's what I'm plugging in the sine right here. You could, I think, write it as that, what we had here. But I think this just looks cleaner. So let's just plug it like that. 2 times 3 x times 3 to the power x natural log of 3. And then, I don't know, we had the, yeah, and then we still gonna have the natural log of 7. And then we just still have the, on the bottom, we still have that. Just make it so you can see it good. And we still gonna have 5 log base 7 of x plus sine squared. And let's move it. So should have wrote it a little bit better. Nope. Am I gonna get lucky? There you go. There you go. Okay. Then what else do we have? We had the 3 to the power x. Then close that squared. But then we still have that 1. So let's move that. Yep. Okay. Plus 1. But the thing is, all that is in the parentheses. So there you go. Like that. And that is the final answer that we got. Yep. This is it. So let's box it in. Make it like a color that I haven't really used. Red. So you can see it. That's the final answer. Okay. And that's Math with Jon. Till the next one.